Hey, Reese.
Hey, Miss Sparks.
How are you, sweetheart?
I'm good. How are you?
I'm doing good.
Good. Well, let me get my stuff out.
Okay, sweetie. Oh, there's Eli.
Okay.
All right. Hey, Eli. How are you this morning?
Good.
Good. Oops. I was trying to also post the class notes, like the rest of those, to Google Classroom because I didn't do it yesterday. Some of the other ones so that y'all have plenty of examples.
Mm-hmm. Yeah. I haven't finished the notes yet.
I just got those posted. That's what I was finishing doing.
Oh, okay. All right. Perfect. Thank you.
Yeah, no problem. All right. So basically what you want to do is we're just kind of continuing, like I said yesterday, we're continuing the concepts that we started working on Monday. Nothing changed with regard to finding the axis of symmetry and the vertex. Nothing changed about that. We just added some additional exercises to do. And we're also, instead of just drawing a plain old dotted line as the axis of symmetry, and then showing that the vertex is that, the turning point or that pivotal point on the cup-shaped, parabola, we're actually putting it on the coordinate plane now and taking a look at the domain and range. So we're just adding to the concepts. So the axis of symmetry, as we remember, is the formula, the opposite of B over 2A. And we just apply that. So on number 1, what is our B value?
-2.
Yeah. So we would actually plug in that opposite of 10 over, and then A is 1. So 2 times 1. So that's going to be -5 because 2 times 1 is 2, and then -10 divided by 2 is -5. So our axis is, hey, how are you, Grayson?
Good.
Our axis of symmetry, 1, 2, 3, 4, 5. Is going to be this imaginary line, if you will, running through the -5 position on the x-axis, all the way top to bottom. So the next thing that we're going to do then to find, okay, that also is our x coordinate of our vertex. And to find the y coordinate of the vertex, we're going to plug in -5 back into the equation. So we have -5 squared, which is going to be +25. And 10 times -5 is -50. Plus 26. So 25 plus a -50 is a -25. Plus 26 is going to be a +1. So our vertex is y equal, our vertex is -5, 1. So we put that in the middle of our table like that. And we're going to go ahead and plot that point. 1, 2, 3, 4, 5. Once again, confirming our axis of symmetry. And it's going to be this point right here on the graph because we're going to go up 1. So then what we do next is fill in our table. We're going to go -4, -3. Oh, technically, I want to go the other way, don't I? I was going down, wasn't I, yesterday in class? Sorry if I messed y'all up. we went -6, -7, and then -4, -3. So obviously I'm going to want to pick that -4, -3 to plug back in, because those are going to be a little bit smaller numbers, a little bit more manageable to plug back into that original equation. And you can do all of this on your calculator, obviously. I'm going to do my work down here on this other problem. Don't let that confuse you. I'll just draw a line through that for now. But this is y equals, and I'm plugging in -4 squared plus 10 times -4 plus 26. So I'll have 16, because -4 squared is 16, plus a -40 plus 26. So 16 plus a -40 is 24, -24, right? And -24 plus 26 is 2. So y equals 2. So if I'm going to plot that point, sometimes I go ahead and plot as I go. 1, 2, 3, 4, up 2. What do I know about this point right here? Based on symmetry, what do I know? What would the y coordinate be? If you had to guess. Based on symmetry, what do you think the y coordinate's going to be? Anybody want to guess? Too afraid to guess. There's my hint.
2.
2. Good job. It is 2, because you know that we're going to have a U-shaped cup opening up, because you have a, so if I go over -6 and then up 2. Okay, because, and now we've already started developing that cup. All right. Good job. Way to go, Kennedy. Way to be brave. And welcome to Math Lab, by the way. All right. So now we're going to do 3. We're going to plug in 3 plus 10 times -3 plus 26. Okay, 9 plus -30 plus 26. So 9 plus a -30 is going to give me a -21. And I'm going to add 26. And so that's going to give me a +5. So if you had to guess, what do you think 7 negative with the y coordinate for 7 is going to be? Right here. What do you think the y coordinate for 7 will be?
5.
5. Good job. And so I counted over. So based on symmetry, you can kind of see the patterns in the y. So if I go over 3, 1, 2, 3, I go up 5. And for the 7, I'm going to go over 7 and up 5. So you see how the symmetry on the parabola works? So there's my cup shape. Good job. Okay, now let's talk about the domain and range. The domain, just like we learned in class yesterday, is what? That's the x variable, or the x coordinate. So what is that? Remember, this is getting wider and wider and wider, spreading itself all the way across the x-axis. So the domain would be what?
All real numbers.
All real numbers. Good job. And then the range is your y. It's connected to your y coordinate. And what is our y coordinate in our vertex?
1.
It is 1. And so remember, when it's a happy face parabola, it's going to be greater than. Because remember, when you're happy in life, things seem to be greater than in life. So happy face parabolas are greater than. So it's going to be greater than 1. You know, bigger than life, big, great, fantastic, life is going well, happy face parabola. So hopefully that'll be a good connection for you guys to kind of remember. The range is connected to the y coordinate of the vertex. So that's going to be 1. And if it's a happy face parabola, it's greater than, because things in life when we're happy seem to be great. And when it's a frowny face parabola, things in life are less, not as happy. So hopefully you'll kind of make those types of word connections to help you figure out exactly how to write the description for the range. All right, number 2. Once again, starting with the axis of symmetry, we're using the same x equals the opposite of b over 2a. That didn't change. What we learned on Monday didn't change. So what is our b value in this equation? What is the b value for number 2?
8.
Good job. It is 8. So x equals the opposite of 8 over 2 times, and what is the a value?
-2.
-2. Good job. So we have the opposite of 8 over 2 times -2 is -4. And -8 divided by -4 is 2. So our axis of symmetry is 2. And the x coordinate of our vertex is also 2. So now we'll take that 2 and plug it back in to our equation to find the y coordinate of our vertex. So y equals -2 times 2 squared plus 8 times 2. So -2 times 4 plus 16. So -2 times 4 is -8 plus 16. So that's going to be 8. So the y coordinate for the vertex is 8. So we'll put that in the middle of our table. And then we're going to go down 2 from our x coordinate and up 2 from our x coordinate to fill in our table. And to get the y coordinates, we'll plug in 2 of our x coordinates, and I'm going to pick the 2 easiest, my total recommendation for you guys as well. So I'm going to pick 1 and 0. So if I plug in a 1, I get -2 times 1 plus 8. So -2 plus 8 is 6. So if you had to guess, what do you think What do you think the y coordinate for the 3 is?
6.
6. No stopping you today, Kennedy. You are on fire. You got this symmetry thing figured out, don't you?
Probably not quite, but I know how to look at numbers.
Yay, you're doing great. All right, so now we're going to plug in the 0. Praise God for multiplying by 0, right? So 0 squared is 0, and 0 times negative 2 is 0, and 8 times 0 is 0. So this is going to be 0. All right, so that being the case, what do you think that the y coordinate for 4 is going to be? Look at the pattern.
0.
0. Good job, Eli. It is 0. So now I'm going to go back. This time I didn't do my axis of symmetry first, but my axis of symmetry is x equals 2. So I have this imaginary line that's running through x equals 2. And then I'm going to plot my vertex. Okay, so that's 2, 8. So I'm going to go over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I need to erase my little arrow because it's in the way. Because it's at the tippy top of my graph here. Okay. And what is the A again? Is it a negative or a positive? Is the A term negative or positive?
Positive.
The A.
Oh, negative 2.
Yes. So will my parabola open up or down? If the leading coefficient is negative, do you have a frowny face or a happy face?
Frowny.
Yes, a frowny face. So we know it's going to be facing down. So we kind of want to keep that in mind before we start putting all these coordinates on here, so that we can make sure we're plotting them correctly. All right, so we're going to go over 1 and up 1, 2, 3, 4, 5, 6. We're going to go over 3 and up 6. We're going to go over 0 and up 0, so that's the origin. And then we're going to go over 4 and up 0. And so based on all of that, we do in fact have a frowny face parabola. And you can see the symmetry. All right, what is the domain for this one? What is the domain for this parabola? Grayson, do you know?
I really don't understand yet, so I'm not sure of anything.
Oh, okay. All right. The domain so far has been what? It's always been the same thing. What has it been?
The domain.
Yes.
All real numbers.
All real numbers. Good job. Okay. And the range has to do with the y coordinate. What is the y coordinate of the vertex? It has to do with the y-coordinate of the vertex. So what is the y-coordinate of this vertex?
8.
It is 8. And it's a frowny face. And remember, I've made the connection that if it's a happy face, things are greater than in life. If it's a frowny face, things are kind of less than in life. So this is a frowny face. So what do you think it's going to be? If it's a frowny face, it's less than in life, right? When you're unhappy, things aren't so great in life. They're less than. So what would it be?
Y is less than 8.
Good job. Y is less than or equal to 8. Good job. Because you do include that value. So y is less than or equal to 8. Good job. All right. Number 3. All right. The axis of symmetry. What is the B value on this one?
Two, -2.
-2. Good job. What is the A value?
1.
1. Okay, so we have x equals the opposite of b, which is -2, over 2 times 1. So the opposite of -2 is a +2, and 2 times 1 is 2. So the axis of symmetry is x equals 1. It is also the x-coordinate of the vertex. And now we'll take that value and plug it back into the original equation to find the y-coordinate of the vertex. So 1 squared minus 2 times 1, 1 minus 2, so that y equals -1. So that's our vertex, which we'll place in the middle of our table. And we can at this time, if we choose to, go ahead and plot our axis, our imaginary axis of symmetry at x equals 1. What is 1 less than? Now we're going to plug in at our table. What is 1 less than 1? I'm going to let y'all tell me what the x values need to be in this table.
0.
0. And what is 1 less than 0?
-1.
Good job. Okay, now we're going to go up. What's 1 more than 1?
2.
2. What's 1 more than 2?
3.
Good job. All right, what of these numbers are the easiest to multiply with? -1 and 0 or 2 and 3? What one would you all? Yeah, I would pick those also. So let's start there. Okay, and we'll plug in 0. Oops. 0 squared minus 2 times 0. So 0 minus 0, that's 0. All right, so now let's plug in -1. Good picks, by the way. -1 squared is 1. -2 times a -1 is a +2. So that equals 3. All right. Based on symmetry, what do you think the y-coordinate is going to be for 2? Grayson, do you have a guess?
0.
Yes. Good job. What do you think the y coordinate for 3 is going to be? Based on symmetry. It's a pattern.
Maybe.
3. Good job. Good job. So now we have all of our points. The first one we're going to plot is 1, -1. So I'm going to go over 1 and down 1. Okay? And let's look back for just a minute at our equation. Is this going to be a smiley face or a frowny face parabola?
Smiley face.
Smiley face, because our leading coefficient is positive. All right, so the next point that we're going to plot is 0, 0. And the next point, and it doesn't really matter which way you do these, by the way. We're going to do -1, 3. Over 1, up 3. And then 1, -1. So, yeah, I already plotted that. Whoops. 2 and 0. I was like, wait a minute, I've already plotted. Over 2, up 0. And then over 3, up 3. So there's our parabola. All right. What is the domain? It's the same as all the other ones. What's the domain?
All real numbers.
All real numbers. That's the domain. And the range is your y coordinate. It's associated with your y coordinate. So it's going to be y. And if you have a smiley face parabola, is it going to be greater than or less than?
Greater than.
Greater than. And what is the y coordinate of the vertex?
-1.
So there's your range. Is this coming together for anybody yet?
Yes, ma'am.
Maybe a little.
Yeah,
Okay.
a little bit.
All right. So we'll just keep working. As you do more examples, hopefully it will. You know, the more practice, the better you get. All right. So what is the B value for this equation on number 4?
-8.
-8. Good job. What's the A value?
-1.
-1. So we're going to plug that back into our equation. The opposite of -8 over 2 times -1. So the opposite of -8 or -1 times -8 is a +8. And 2 times -1 is -2. So that gives me a -4. So my axis of symmetry is x equals -4. That is also the x coordinate for my vertex. And in order to find the y coordinate for my vertex, I will take that value and plug it back into the original equation. So I have this would be, just so you guys know, when that A is a -1, if it would make it easier for you to actually write a -1 here to help you out to remember that when you're calculating, please do so. So that's going to be -1 times a +16 because -4 squared is 16 plus 32 minus 16. So I've got -1 times 16. So that's negative 16 plus 32. So that's going to be 16. And 16 minus 16 is 0. So y equals 0. I'm going to place that vertex in the middle of my table. All right. You guys help me fill in my other x values, please. What is 1 less than negative 4?
Negative 5.
Good job. What is 1 less than negative 5?
Negative 6.
All right. What's 1 more than negative 4?
Negative 3.
And what's 1 more than negative 3?
Negative 2.
All right. Which of these numbers would seem to be easiest to work with for plugging it back in? Negative 3 and negative 2, or negative 5 and negative 6? Which ones do you all want to use to plug back in? To find our y coordinates, you've got to pick 2 of these numbers. Does everybody understand why I'm picking 2, either before or after the vertex? Does everybody understand why I'm doing that?
Yes.
Nope.
Okay. All right. Kennedy, you do understand. Grayson, you do not. Is that correct?
Yes, ma'am.
Okay. All right. Are you seeing the pattern that when I pick 2 of them, either before or after the vertex, that my answers are exactly the same for the other 2? So I really only have to do 2 of them? I mean, I could do all 4, but the symmetry, when something is split in half, the symmetry tells me that those answers are going to be the same. See, over here on this one, we did these 2. We plugged those in, right? On number 3, we plugged in 0 and negative 1. Remember that? Grayson, are you with me?
Yes, ma'am.
I know that the symmetry thing, but I don't know how you get the first 2.
What? Okay. You don't know how I'm picking them, or you don't know how they're filled in on the table, or
Like the table, like I don't know how you get like the 0 and the 3 down there. On
here,
number 3. Yeah,
here, or here.
the top.
That I plugged the 0 and negative 1 back into the original equation, just like I do the vertex.
You mean 0 and negative 1?
I plugged in 0 here, right? What happens if I plug a 0 into that original equation?
Everything goes 0.
Yeah, so that's how I got that 0 for the y.
Oh,
And I plugged
okay.
in negative, I plugged in the negative 1. So you're plugging in, just like you do with the vertex, you're plugging that x value back into the original equation to get the y. Okay? Does that make more
makes
sense?
more sense.
Okay. All right. All right. Now, what did we pick for number 4 as the values we want to plug back in?
Negative 2 and negative 3.
Amen, sister. That'd be the ones I'd pick. So I'm going to take that negative 3, Grayson, and I'm plugging it into this equation to find out what the y coordinate is. So negative 3 squared minus 8 times negative 3 minus 16. So once again, if you want to, when this a is a negative 1, go ahead and write it down here so that you're not forgetting to multiply, because it multiply your answer that's in the parentheses, your negative 3 squared. That's a 9. Go ahead and write a negative 1 to help you remember to multiply that by the negative 1. And then negative 8 times negative 3 is a positive 24 minus 16. So I've got a negative 9 plus 24, so that's going to be 15 minus 16. So y equals negative 1. And now I'm going to plug in negative 2 back into my original equation. To find out what the y coordinate for negative 2 is. So, negative 2 squared is a positive 4. Negative 8 times negative 2 is a positive 16. So I have negative 1 times 4, which is negative 4. And negative 4 plus 16 is 12. And 12 minus 16 is negative 4. Okay. Grayson or Eli, what would the y coordinate be for negative 5?
Negative 1.
Negative 1. Good job. What would the y coordinate for negative 6 be?
Negative 2. Negative 4.
Yes. There you go. Good job. Good job. All right. So now let's graph that axis of symmetry. That's going to be negative 4. 1, 2, 3, 4. So that's this dotted imaginary line that splits the parabola down the middle, creating the symmetry that we keep referring to. Okay? There's our axis of symmetry. Our vertex is negative 4, 0. So it sits right here. And our A, is it positive or negative?
Negative.
Negative. So do we have a frowny face parabola or a happy face parabola?
Frowny face.
Frowny face. It's negative. Good job. All right. So now let's plot some of our other points to confirm that it is in fact a frowny face parabola. So we're going to go over left 3, 1, 2, 3, and down 1. We're going to go over to the left 2, 1, 2, and down 4, 1, 2, 3, 4. And now we're going to go left 5 and down 1. And we're going to go left 6 and down 4. This creates our symmetry, and we have a frowny-faced parabola. All right, what's the domain?
All real numbers.
All real numbers. Good job. And the range is what?
Less than?
It
Or
is
equal
less
to?
than. And it's y is less than what?
0.
0. Good job. because it has to do with the y coordinate of the vertex. The less than is because it's a frowny face. And because it's dealing with the y, it starts with the y variable. So y is less than 0. All right. What is the b value in this equation? Don't let it trick you.
0.
0. Good job. There is no b because this is the constant. The b always has the x variable to it. Good job. This could be rewritten like this if you would like to. The b value is connected to the x variable without an exponent. So what is the a in this one? What is the a value in this one?
3.
3. Good job. So x equals the opposite of b over 2 times a. So that equals 0. So our axis of symmetry is x equals 0. And 0 is also the x coordinate of our vertex. And to find the y coordinate of the vertex, you'll plug in the x value back into the original equation and solve for y. So y equals 3 times 0 minus 5. That's 0 is squared. Not that it will really matter because 0 squared is 0 and 0 times 3 is 0 minus 5. So y equals -5. And typically you can always think when your x is 0, it's usually going to be just the constant. So there's our vertex. We'll place that into the middle of our table. And what is 1 less than 0? Grayson, tell me how to fill out this table. Help Kennedy out. She's been doing it. Grayson, what is 1 less than 0? What's 0 minus 1? Are you still with me?
-1.
-1. That was Eli though, wasn't it? I was like, is Grayson too shy? Thanks for taking one for the team. Eli, what's 1 less than -1?
-2.
Good job. All right, what's 1 more than 0?
+1.
Good job. What's 1 more than 1?
+2.
Good job. All right, are y'all seeing how to fill the x portion of the table out? Is that becoming clearer to everybody yet?
Yes.
Yes, ma'am.
Okay, good. Grayson, are you still with us? Is that better for you? How to fill out the x part of the table? Did he leave me? Is he broken? All right. Which one of these do y'all want to deal with as far as plugging the x values back in to find 2 of our answers? Which ones do y'all want to pick?
1 and 2.
All right, let's do 1 and 2. That's be what I would pick too. Negative numbers aren't bad, but positive are a little easier. Not gonna lie. All right. So we have 3 times 1 squared. 1 squared is 1. 3 times 1 is 3 minus 5. So y equals negative 2. So what other answer do you think is going to be negative 2? What other x variable's probably going to return a negative 2?
-1.
Yes, good job. Negative 1. So we could go ahead and put that in there if we wanted to. All right. 3 times 2 squared minus 5. 2 squared is 4 minus 5. So that's 12. Oh, minus 5 equals 7. All right. So what other coordinate is going to return an answer of 7 if we plugged it in?
7 or -7? Maybe. Probably
7.
not. Oh, yeah.
What other coordinate is going to give us an answer of 7? If I plugged in what would give me a 7? There's only one block left.
-2.
Yes, negative 2. Good job. All right, are y'all seeing the pattern? Grayson, are you seeing the pattern yet?
Yeah. I think so. Sorry.
You think so? Look at the y side right here. We plugged in this first, right? And you know how we got those values, right? We did that on Monday and Tuesday. You understand how we got the vertex, correct?
Yeah, I got that myself.
Oh, okay. And are you still confused on how we're getting these?
No, I can do the whole X side. That's easy.
Okay.
And then
All right.
to do the Y side, don't just plug in like -1 into the equation and then -2 into the equation or something? Wait, no, that doesn't
Yes.
make sense.
No, you do, but we picked 1 and 2 because we would have rather you pick the ones that look easier to work with. Because you can pick either side of the vertex. And dealing with positive numbers was a little easier than dealing with the negative numbers in this instance. So you're free to pick either side of the vertex, the top side or the bottom side. Does that make sense? If I said to you, Grayson, I want you to either work with 7 and 8 and multiply those numbers or work with 0 and 1, which would be the ones you would pick?
0 and 1,
Okay, why would you pick those?
because they're easy.
There you go. So that is why you pick either the top above the vertex or the bottom below the vertex. You have the option to pick whichever 2 numbers are easier to work with because you know the rule of symmetry is going to give you the other 2 answers. Does that make any sense? Better sense to you now? Or still not yet?
Yeah, it's making a lot more sense now. I think I can do just about everything for the most part, except for the graphing. Well, I might
Okay.
could do that. I don't know.
All right, well, let's work on the graphing. I'm going to plot 0, -5. So that means I'm not going to go right or left any for the 0, and I'm going to go down 5. 1, 2, 3, 4, 5. All right. So there's my vertex. And now I'm going to look back over here. Am I going to have a smiley face or a frowny face parabola?
Smiley face.
Smiley face. All right. Good job. So now just to confirm, I like to have an idea of what I'm working with before I start plotting my points, because I want to make sure that my shape is coming out right once I start putting my points on my graph. That's why I check that. So my smiley face parabola. So now I'm going to plot this point, -1, -2. So I'm going to go over left 1 and down 2. And then I'm going to plot -2, 7. So I'm going to go left 2 and up 7. 1, 2, 3, 4, 5, 6, 7. And now I should get a point right here. And let's just make sure. I know that because of symmetry, but let me go ahead and now count my points. Right 1, down 2. And in fact, that's absolutely correct. I also know that I should have one right here based on the rules of symmetry. But let me just check it by counting. Right 2 and up 7. 1, 2, 3, 4, 5, 6, 7. That's it, exactly. And there's my parabola. Okay? So what is my domain?
All real numbers.
All real numbers. Good job. And my range deals with which coordinate, the X or the Y? The range deals with X or Y. Are Kennedy and Reese still with me?
I am, yes, ma'am.
Okay. Oh, hey, Roger. Anybody want to tell me which coordinate does the range deal with, the X or the Y?
Y.
Y, good job. And when you have a smiley face parabola, is it going to be greater than or less than?
Greater than.
Greater than, good job, because things in life are greater than when you are smiling, happy, open. All right, so if it's going to be greater than and it deals with the Y coordinate of the vertex, Y is going to be greater than what? What is the Y coordinate of the vertex?
0.
The Y coordinate.
-5.
-5. Good job. -5. It's the Y. All right, good job. So Y is greater than -5. Is that coming together for you guys at all? The range?
Yeah, it makes sense ish.
Ish. All right. Um, all right. What is the B? Hold on just one second. I know. Sorry, we had a bug emergency in our house. It was actually outside in the driveway, but it was scary. Hate those bugs. Stay on your own turf. All right, so the B value is 12. And the A value is what? What is the A value for number 6?
-2.
-2. Thank you, Kennedy. So we've got the opposite of B over 2 times -2, because that's the A value, which equals -12 over -4, which equals 3. So X equals 3. That is also the X coordinate of our vertex. And so we'll use that value, 3, to plug back into our original equation. -2 times 3 squared plus 12 times 3 minus 15. So -2 times 9 plus 36 minus 15. So -18 plus 36 minus 15. So that's going to be 18 minus 15. So that's 3. 18 minus 15 is 3. So the vertex is 3, 3. All right. Help me fill out the rest of this table. What numbers am I going to put in there? On the X side, what numbers am I going to put in?
Two higher, two lower.
Okay. And what would those be? Go ahead and just tell me what to write down.
1 and 2, and then -1 and 2.
Or you could actually do 4 and 5. You could do -2 and -1, but you want to just go up from there. So basically, love you. Basically, this just says 1, 2, 3, 4, 5. So you want to go 2 higher and 2 lower. But I see where you're going with the -2, -1. But if we want them to match, you want them to actually just go in increments of 1. Does that make sense?
Yes, ma'am.
Okay, cool.
I think I was reading off of one of the other ones that I had done earlier.
Oh, there you go. And, other points would work, but if you're trying to watch that rule of symmetry, it's always cool to keep them within like one of each other. That makes sense. So now, which 2 do you want to work with, Kennedy? When you're plugging those values back in to find the Y coordinate, which 2 do we want to work with?
1 and 2.
Right. Grayson, do you understand why she picked 1 and 2?
Yeah, up to now it makes sense, and I think the Y is starting to make sense. I think, yeah,
Okay. All right. But you understand why she picked what she did, right?
because it's easier.
Yeah. That's it exactly. So tell me what to do next, Grayson. Kennedy helped me out so far, and she told me how to fill in the table, and she told me to pick 1 and 2. So what am I going to do next? How am I going to get those Y values?
What you do next? You plug
Yes, sir.
plug 1 into the equation, and then you plug 2 into the equation. And
You're absolutely right. Do you care what order I do them in?
no,
Okay. I'm going to plug in 2. And I got -2, and then 2 squared is 4, plus 12 times 2 is 24, minus 15. -2 times 4 is -8, plus 24, minus 15. -8 plus 24 is 16, and 16 minus 15 is 1. Hey, Grayson, what other one do you think is going to have an answer of 1?
1.
What other X value is going to have an answer of 1?
1.
Oh, you're saying this one? No.
Oh, oops.
Symmetry.
Oh, 4, 4. I didn't understand the question.
Yes, good job. Good job. It's going to be 4. All right, because we're working on that symmetry now. All right, 2 times 1 squared plus 12 times 1 minus 15. So -2 times 1 squared, which is 1, plus 12 minus 15. -2 plus 12 minus 15. -2 plus 12 is 10, and 10 minus 5 is -5. So what other one is probably going to give me -5 as the answer? Eli, do you have a guess?
Eli left.
He left.
Yeah, it's Eli's birthday, he said. He's going to eat lunch.
Oh, okay. All right. Well, what other one is going to give an answer of Roger? Are you still with me? What other one is going to give me an answer of -5? What X value, only one left, is going to give me an answer of -5?
5.
Yes, good job. 5 is also going to give me that. So I'm going to plot that axis of symmetry. It's going to be a vertical line that runs through the X coordinate at 3. A vertical imaginary line that runs through at the 3 coordinate. All right. And then we have a vertex of 3, 3, 1, 2, 3, up 3. So it's going to be right there. I'm going to look back over at my equation. Is this going to be a smiley face or a frowny face parabola?
Frown.
Frowny face. All right. I like to bear that in mind before I plot the rest of my points to make sure I'm kind of going in the right direction. So I'm going to go over 2, up 1. So it looks like we're going in the right direction so far. Over 1, down 5. 1, 2, 3, 4, 5. All right. Over 4. 1, 2, 3, 4. Up 1. Over 5, down 5. And so there's our symmetry, and we have our parabola. What is the domain? What is the domain? What's the answer for the domain?
All real numbers.
All real numbers. What is the answer for the range?
Y is less than or equal to 3.
Absolutely. You said it so perfect, Kennedy. I'm so very proud of you. That is awesome. Way to go. You go, girl. All right. All right, number 7. What is the B value? Make sure this one doesn't trip you up. Grayson, what is the B value for number 7?
Oh, 0.
0. Good job. What is the A value?
-1.
-1. So I've got the opposite of B over 2 times -1, which equals 0 over -2, which is just 0. So my axis of symmetry is 0. It is also the value of the x-coordinate of my vertex, which I will put back into the original equation to find my y value of the vertex. So I'll plug that 0 back into the original equation. Y equals the opposite or -1 times 0 squared plus 1. Y equals 0 squared is 0. 0 times -1 is 0 plus 1. So y equals 1. And remember what I said before, when there's no B value or when there's a 0 in for x, it's going to be that constant. The answer is going to be that constant. So there's our vertex, 0, 1. All right, help me out and filling this table out. What's 1 less than 0?
-1.
Good job. What's 1 less than -1?
-2.
Good job. What's 1 more than 0?
1.
Good job. What's 1 more than 1?
2.
Good job. So now our x's are filled out. And Kennedy, which one's going to be easier to work with? -1 and -2 or 1 and 2?
+1 and 2.
Amen, sister. I'm right there with you. So we're going to plug in opposite of 1 squared plus 1. So that's going to be -1 times 1 squared, which is 1. So we've got -1 plus 1. So that's going to be 0. So what other answer is probably going to be 0?
-1.
Yes, good job. That's it exactly. All right, already working on that symmetry. And then we're going to plug in, probably shouldn't have erased that, actually. I could have just used my parentheses that I had there. Ugh, I hate it when it starts scooting like that. Now I have to rewrite everything. It's like it doesn't want to be erased, so it's running away. So now I'm going to plug in my 2 into my original equation to find the y coordinate. I plug in, anytime I want a y coordinate, I plug the value of x back in. Four plus 1. So -4 plus 1. So that's going to be -3. So what other answer is going to be -3?
-2.
Good job. So now I'm going to plot my axis of symmetry, which is x equals 0, which is just really the y-axis. Okay. And then I'm going to plot my vertex, which is 0, 1. And now I'm going to plot 1, 0. So I'm going to go right 1, Oh, I forgot to look whether it was a smiley face or a frowny face. And I was like, wow, is this going to be right? And then I looked over and realized it is going to be a frowny face. So I'm going in the right direction. That's why a lot of times I've said in the past, I was like, always check to figure out whether you're going to have a smiley face or a frowny face parabola, so that when you begin plotting points, you're not second guessing yourself. Oh, am I going the right direction? Because it should be going down. So I'm going to go left one, and then not moving up or down any. So I'm going to go right 2, down 3. And then I'm going to go left 2, down 3. So there's my parabola. All right, what's the domain?
Oh,
Bless you.
Oh, thank you.
What's my domain?
All real number.
All real numbers. What's my range?
Y is less than or equal to 1.
Good job. Y is less than or equal to 1. Good job. Way to go. I'm so glad you're putting all of that together. Okay. What is last one? What is the B value for number 8?
$16.
Yeah, negative 16. So when you plug it in and you take the opposite of negative 16, you're going to get a positive. And what is the A value?
2.
Good job. So 2 times 2. So we have the opposite of negative 16. Oh, I got scary for a second. Okay. The opposite of negative 16 is a positive 16. 2 times 2 is 4. And 16 divided by 4 is 4. So my axis of symmetry is x equals 4. It is also the x coordinate of my vertex. And to find the y coordinate of my vertex, I will take that 4 and I will plug it back in to the original equation. 2 times 4 squared minus 16 times 4 plus 30. 2 times 16, because 4 squared is 16, minus 4, 64 plus 30. So 32 minus 64 plus 30. 32 minus 64 is negative 32, plus 30 is negative 2. So there's my vertex. I put my vertex in the middle of the table.
Oh wait, okay, hold on. Can I ask one quick question?
Yes.
My brain just completely went blank, and I forgot how you got -2.
I plugged in the 4 back into the equation.
Oh yeah, I thought that's what you did. I'm sorry, I just wasn't thinking.
No, that's okay. You just plug the 4. That was the same thing we did on Monday and Tuesday. And that's really what you need to do for all of these values. Okay? To find the y value, you plug the x back in. That's how you get the y. You have to plug the x in to get the y. The x is the independent variable, and the y is the dependent variable. Kind of like science, when you have an independent and dependent variable, x is the independent variable. So that's what you're plugging back into the original equation to find out what y is. All right, let's fill in the rest of this table. What's 1 less than 4? One less than 4.
Three.
3. Thank you. And 1 less than 3?
Two.
What's 1 more than 4?
Five.
And 1 more than 5?
Six.
Good job. Grayson and Roger, why is it jumping so bad? Are you all seeing how to fill in the X side of the table?
Yes, ma'am.
Okay. Okay, good job. All right, which two of these variables, Grayson, should we work with? 2 and 3 or 5 and 6? We're plugging them back into the original equation. So which two do you want to work with? Grayson?
What do you want? I'm confused.
Okay, you have to pick either the two x's before the vertex or the two x's after the vertex to plug back into the original equation to get your y coordinates.
The
Would you
3
want to
and
work?
2 are going to be easier.
Right, so we'll pick those. And what do we do with them? What do we do with the 2 and the 3?
Put them back in, plug them back in to find your y.
Yes. Grayson, is that making sense to you? Good job, Kennedy.
Yes, ma'am.
Oh, okay. All right. Plug them back into the original equation. So we'll start with the 3. You have 2, and then 3 squared is 9. Minus 16 times 3 is 48, plus 30. We have 27 minus 48 plus 30. Oops, my bad. I can't multiply. That's 18. I was like, wait a minute. That doesn't look right. I multiplied 9 times 3. So it's 18 minus 48 plus 30. So 18 minus 48 is 30, negative 30, and negative 30 plus 30 is 0. So, Grayson, which other one on the table do you think is going to have an answer of 0?
5.
Yes, that's it exactly. 5. So now we'll plug in 2. 2 times 4 minus 32 plus 30. 8 minus 32 plus 30. 8 minus 32 is a negative 24. And negative 24 plus 30 is did I do that? Oh, yes, is 6. All right, what other answer is going to give me a 6? What other x coordinate is going to give me an answer of 6? Are you there, Grayson?
Yeah.
What other?
6.
Yes. Good job. What is the domain?
All real numbers.
What is the range?
Y is greater than or equal to -2.
Good job. Amen. You did great. So you understand all of it.
And yeah, I guess the graphing's weird. I don't like graphing.
Okay. Am I graphing? Okay. So what am I doing first? What am I doing right now?
Over 4 down 2.
Well, what did I just do? What did I just draw?
Oh, a straight line that's over 4.
Yes. And what is that called?
A line.
Yes. And specifically for this problem, what's it called?
Axis of symmetry.
Good job. And now you're right. I'm going to go over 4 and down 2. And what did I just plot? What's that called? What's that special point called?
Vertex.
Good job. And now I'm going to plot the other points on the line. I'm going to go over 3, 1, 2, 3, and not moving up any. I'm going to go over 2 and go up 6. 1, 2, 3, 4, 5, 6. And then I'm going to go over 5 and not go up any. And my symmetry's already there. And then over 6, up 6. And there's my symmetry. And I've got my U-shaped parabola. Okay.
Thank you.
Yes, you're welcome. Have a great day. Thanks for coming to Math Lab.